Hi everyone, in the previous video, we spoke about the output file export of our software Pick and Place Easy. Today, we are going to discuss how to manage the SD card on the Pick and Place machine Neoden YY1. We are also going to check all the data we set in the software and see if they are coherent with the placement phase. Well, we are in front of the machine. The SD card has been inserted into the dedicated slot located on the right side. The biggest display here shows the 4 files generated by our software. Let's have a deeper look at each file. Neoden YY1_TL01.csv. Let's tap on it and then on Edit Component. We see on the top right-hand corner that we have 4 components on the top layer during the first pass. The first component is U10 with the comment ESD8104MUT. The skip information equals 0 showing the component is mounted. The mode equals 1 showing a camera mode. Let's have a look in Altium Designer to the dimensions of the component. We have length 2.5 mm, width 1.0 mm, height 0.3 mm. Both length and width are smaller than the maximal threshold we entered for camera recognition, which is coherent. The placement height information equals to 0.3 mm, which is also the height of the component. This is particularly coherent in order to avoid any mechanical stress on the board when placing the component. The mounting speed is 100% according to our setting. Let's check the rotation now. We remind that the reference is the footprint in Altium. The orientation on tape, according to the datasheet, is 90 degrees clockwise from footprint. The orientation on PCB is 180 degrees clockwise from footprint. Consequently, the rotation computed by our software equals 180 minus 90, giving 90 degrees. And that's exactly what we have here on the display. We also have an associated feeder assigned to tape feeder number 1. Let's check the other components. U11, U9, U8. All are mounted components and the settings are identical to the first one, U10. This validates the settings for the top layer on the first pass. Let's have a look now at the second pass for top layer. Let's click on the file Neoden YY1TL_02.csv. In accordance with our settings, we have 2 components D12 and D9. They are both mounted in camera mode thanks to their dimensions. Associated feeder is tape feeder number 2. Well, everything looks fine for top layer. Let's check now the bottom layer for both mounting passes. The first pass adheres coherently to the settings with components FB3 and R2. They are both mounted. Associated feeders are tape feeders number 3 and 4 respectively. The second pass also adheres coherently to the settings with 7 components C42, C41, C40, C39, C38, C37 and C36. They are all mounted. The 6 first components are assigned to tape feeder number 5, the last one to tape feeder number 6. Well, we are done with all the settings imported in the Pick and Place machine. Now we are going to enter the placement phase on the Mezzo docking board we have here. Since we have just set a few components, we won't assembly the board for real. The placement will be simulated through the option Edit Component, allowing to demonstrate the exact placement location for each component. We will do it for 1 component on each layer. As you can see, components should be mounted on both top and bottom layers. Let's dive in with top layer first. We are going to place the board onto the machine, according to the settings in the software. We selected PCB orientation following Altium orientation, meaning that the board should be placed like that. We kindly remind that the origin of the board, for the machine, is always on bottom left corner. First we are going to set the PCB origin. For that we use the option manual test on the home page. We are going to use the white arrows in fast and slow modes here to move the center of the red cross on the small display exactly onto the PCB origin. We can use the zoom icon here to have a better view on the board corner. When achieved, let's write down on a paper the coordinates x and y displayed here on the top right-hand corner. X equals 71.95 mm. Y equals 76.45 mm. Now we have to enter this information. Let's tap on the option parameters on the home page. After having entered the password, let's set the x and y coordinates of PCB origin according to the ones we wrote down a few minutes ago. Don't forget to save before exiting the page. Before starting the placement, we strongly recommend to set a fiducial on the board for better placement accuracy. Please follow the Neoden user manual to do so. Assuming having set the fiducial, we are now ready for the placement testing procedure. Let's start with top layer and component U8. For that, let's tap on the option Edit Component from home page and select the last fourth component through the dedicated arrow on the top right-hand corner. This action induces the displacement of the nozzle just over the component. The small display shows here the perfect alignment of the place location with the component center. Let's continue with the bottom layer. For the presentation, we will use the first pass with component R2. After having placed the board at the same origin than top layer and setting the fiducial, we are able to trigger the option Edit Component. The dedicated arrow on the top right-hand corner allows us to reach component R2. This action induces the displacement of the nozzle just over the component. The small display shows here the perfect alignment of the place location with the component center. Well, we are done now with the testing phase for the placement. We tried to show the perfect coherence between the data set in our software pick and place easy in the components to be populated on the board. I hope you enjoyed this video and please use the comments below to ask questions if any. Feel free to click on the thumb up if you like this video. You can also subscribe if you don't want to miss any video from our channel ADiS Music GmbH. In the next and last video, we'll present the tabs About, Help on Settings and Help on Components and Feeders. Thanks again for your time and see you soon.